Hey everybody, welcome back into another fun and exciting algebra class. I am glad that you're here today watching. I hope that you learned something. Today we are going to be talking about some properties or laws of algebra. Last class we kind of talked about mathematical laws and how we can transform those into formulas. Well, today we're going to talk about algebra laws that are going to help us all year long. And if we can learn these and if we can apply these, then you'll see that the work becomes easier and easier because you know the laws, you know the rules of algebra. So here they are. The first one we want to look at is called the commutative. Commutative. I've heard some students and even some teachers call this the commutative or something like that. It's not commutative, it's commutative. Commutative. Okay? And so that's how you say that, commutative. And the commutative property, here's what it means. You can take 1 plus 2 and you can flip it. You can turn it if you want to, and that obviously equals 3. Or we can say 2 plus 1, and guess what? Yeah, that also equals 3. Ta-da! Okay? And so that's commutative. It's not that hard of a principle or property to understand, and you've been doing that for a long time. You can take addends and switch them, and it's the same thing. In algebra, here's what it looks like. X plus y equals, and then is the same as y plus x equals. And we don't know what y and x are, so we can't really say what they equal. But that's how you do it in algebra. You can just flip them. You can switch those. Okay, so with addition, it works. And let's look at what happens with multiplication. Okay, so addition, it works. Let's look at multiplication. Let's see if it works in multiplication. So we have 2 times 3 equals 6. How about 3 times 2? Yes, that also equals 6. It also works in multiplication. So you could have xy equals or yx equals. They both mean the same thing. So here's what they're trying to tell you with the commutative principle. You can switch things around. You can change the order. When can you change the order? In any addition problem, you can change the order. In any multiplication problem, you can change the order. Okay? Now watch this. Here's a problem. What about when we try subtraction? Okay? So addition, yes. Multiplication, yes. Subtraction, let's take a look at it. 3 minus 2 equals 1. 2 minus 3 equals -1. Whoops. It does not work in subtraction, okay? Commutative does not work in subtraction. How about division? How about division? Some of you are already thinking, no, I don't think it's going to work. You're right, it doesn't work. I'll spoil it just a little bit. So what do we have? Let's say we have 12 divided by 4, and that equals 3. What if we have 4 divided by 12? That doesn't equal 3. That equals 1/3 if we reduce it, okay? So subtraction, no. Division, no. Addition and multiplication, yes, those work, okay? Commutative, you can switch things around. I would suggest, let me just take just a minute here. I don't have much time, but let me take a minute here. You need to write this stuff down. You need to write it down. Get a notebook, get a piece of paper, and start writing. Use your hand, use your pencil, and start writing. Don't just look at it in the book. Don't just watch it on the video. Write it in a notebook. Why? Because there's all kinds of studies that have been done that says when you think something, when you read something, when you hear something, you kind of learn it. But when you write it, that reinforces it, and that helps you learn it even better, and that's going to help you on your quizzes and tests if you're writing things down, okay? All right, the next word that I want to talk about is the associative principle, the associative. The word sounds like what it actually is. When you associate with someone, That means that you hang out with them. That means that you're in their group, okay? You're together with them because you associate with them. All right, so here's what it means in math. If I have a plus, well, let's do it with numbers first. If I have 1 plus 2 plus 3, that equals 6. If I have 1 plus 2 grouped together plus 3, what does that equal? Well, we have to do that first, right? What's that? Because it's in parentheses. So that's 3. 3 plus 3 is 6. Now watch this. What happens if we change the grouping? 1 plus 2 plus 3. And we group those together. Okay? So now, again, we have to do this first. 2 plus 3 equals 5. 5 plus 1 equals 6. No matter how we group addition, we can put them in whatever groups we want to. And this is going to be super, super important in algebra right here. This is probably the most important principle that you learn. If not, then one of the top 1 or 2. Okay? Very important. Make sure that you learn this. You can group addition together. So addition, it works. How about multiplication? What do you think about that? Well, let's say we have 3 plus, well, we're multiplying, 3 times 3 times 2. 3 times 3 times 2 equals, okay, 18. What happens if we group them together? 3 times 3 times 2. We're going to group these two together. So we got to do this first. 9 times 2, 18. 3 times 3 times 2. Let's group these ones together. So let's do this first. 6. 6 times 3, 18. Multiplication, yes, is associative. We can group multiplication any way we want to. We can group addition any way that we want to. Okay, so let's look at subtraction. 3 minus 2 minus 1. Okay, 3 minus 2 minus 1. So if we just do that straight across, we get 3 minus 2, 1, 1 minus 1, 0. All right, so now let's group them together. Well, if we group them like this, we also get 0 because we just do that one first. Now let's do it the other way. Let's do 3 minus 2 minus 1 grouped together. Okay, so we have to do this one first. So 3 minus 2 minus 1 is 1. 3 minus 1 is 2. Whoops, that one didn't work. Okay, now let me show you something that's interesting, and it doesn't work and it does work at the same time. Let me show you a way, and I'm going to kind of introduce the next word, which is called distributive. We're going to distribute, and I'm going to show you a little secret here. If we distribute the minus sign, okay, then we can actually make this work out better. Well, let me save that. I'm just going to save that. I'm going to leave that there, and I'm going to save it for distributing. I don't want to get ahead of myself. I want to explain what distributing is. So subtraction doesn't work, and then division, I won't take the time, but it does not work either. Okay. All right. So distributive. So let's jump back to distributive now. Here's what it means. To distribute means to give one to everybody. Okay. Maybe you've seen the show before. It's an older show, but Oprah Winfrey had her own show on, and she had a talk show. And one day she came out and she said, "You get a book, and you get a book, and you get a book." And she gave everybody in the whole place a book. And so everybody was happy. Hey, we got a book. And then one day she came out on her show and she gave away something else. And she said, you know, you get a, whatever it was she was giving away, a new kitchen blender or something. You get a blender, and you get a blender, and you get a blender. And everybody got a blender. And she kept saying, and you get a blender, and you get a blender. And then one day she came out, and believe it or not, she did this. This is real. She said, you get a car, and you get a car, and you get a car. And she gave everybody in the whole building, everybody that was watching her show, she gave them all a car. What was Oprah doing? She was giving away a lot of money. But what was she doing? She was distributing. She was distributing things. She was making sure everybody got one. Okay? And so this is what distributing is. So let's take a look at what this means. If I have a 3 and then a parenthesis, 4 plus 2. Now I'm showing you this without any algebra right now because I want you to see that it actually does work. And then I'll show it to you with algebra. So now, order of operation tells us to do this first, correct? Okay? So we would get 3 times 6, and that would be 18. Okay? 3 times 6 is 18. Now, watch this. I'm going to show you the way. This is now, instead of doing it that way, in algebra, we can take a little shortcut. We can do it a little interesting, a little different way. We can distribute the 3 to the 4 and the 3 to the 2. So basically, you get a 3 and you get a 3. Everybody gets a 3, okay? We're like Oprah here. We're giving everybody a 3. So we distribute the 3 to the 4. 3, and remember, there's no sign here, so it's 3 times 4. Okay, and 3 times 4 equals 12. Keep your plus sign. 3 times 2 is 6. Wow, we still got 18. That's magic. Not really. That's algebra. Okay, that's algebra. That's the distributive property. Now let's do one of those with a letter instead. So let's say that we have a 3 outside and we have an x plus y inside. Okay, so we want to distribute, because now here's the thing about algebra, we can't do this anymore. You say order of operations says to do inside the parentheses. You can't do inside the parentheses. There's no way to do that. There's no way to solve that. So here's what we're going to do. We're going to distribute. And we get 3x plus, 3y. The x gets a 3 and the y gets a 3. We're distributing. You can also distribute a negative sign. So if that had a minus, we'd get a minus 3xy. And we would get a minus 3y right here. So we can also distribute with a minus sign. So next one is identity. And that one is exactly how it sounds. The identity property means identity. In addition, what is the identity? In addition, it's plus 0. If you add 0 to anything, you get its identity. 7 plus 0 equals 7. 10 plus 0 equals 10. You see where the identity is? 7 and 7, 10 and 10. Okay? In multiplication, what's the identity? Times 1. Times 1. Okay? 7 times 1 equals 7. 10 times 1 equals 10. All right? So the identity in multiplication is 1. The identity in addition is 0. Very important to understand that. Most of you already know that. That's just kind of a review thing right there. All right, the last one is called the inverse. The inverse. Now, the inverse, there's kind of a couple different ways to look at this. One of the ways is this. We're going to flip the fraction. 1 over 4. What is 1 over 4's inverse? Well, it's 4 over 1. That's an inverse. You take the fraction and you flip the fraction. Now, I want to show you something. Every inverse always equals 1. Every inverse always equals 1. So we could do it a couple different ways here, but if we cross-canceled, we get 1 times 1 equals 1, 1 times 1 equals 1, which equals 1. Every inverse will always equal 1. Let me show you another inverse, another type of an inverse. This is an inverse of a negative number. So you'd have a 2, and its inverse is negative 2. 2, and its inverse would be negative 2. So that would be inverses with positive and negative numbers. Inverses with fractions. Let's see. Oh, so, okay. So let me write this. So the inverse with fractions, that's with fractions. Fractions always equal 1. The inverse always equals 1. But with positive and negative numbers, the inverse always equals 0. The inverse is always going to equal 0 on those. Okay? So positive negatives are going to equal 0. That's the inverse. And then in fractions, it's always going to equal 1. That's the inverse of a fraction. Okay? All right. Hope you learned something today. Those are going to be super important. We're going to keep using those all year long. So you better learn them right now. Very, 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 very important principles we just learned right there. Okay? All right. We'll see you later. Bye.